For this week's assignment, we'll be doing some art and we'll use our pictures to understand and interpret the geologic features of bodies in our solar system. This image is clearly not to scale, but it highlights some of the differences in the surface features of the planets within our solar system. And their moons are also very different, and those differences have much to teach us about what happened on these astronomical bodies in the past. Here's an image of a small asteroid, Eros. It's too small to have been formed into a sphere because gravity will cause astronomical objects to be spherical if they're large enough. Eros is small. Nevertheless, it shows craters, evidence of past impacts that it sustained, sometimes in the very distant past. Here's an image of a comet, and you can see that the craters are less distinct. A comet is different because it's composed of lots of ice, lots of material that outgasses as the comet orbits around the sun. So there's been some weathering on these craters that we don't see on asteroids because they have no atmospheres and no gases that come off, or liquids. So geology has many of the elements of art. We can use these elements to understand geologic features of astronomical bodies. The first and most obvious is shape. We've said that circles are indicative of craters, and we can imagine the impacts that generated these craters. Imagine dropping a rock into a bag of flour, and what would result would be a circle, a circular crater in that bag of flour. Here are some circles on Mercury, and we can read the history from the cratering that's happened. For example, take a look at this large crater here. There are smaller craters within it that wouldn't be there unless these impacts had happened more recently than the large impact. If they had been there before the larger impact happened, they would have been obliterated by whatever caused this larger impact. So we can start to make statements like that about the kinds of impacts that happened in the distant past and more recently on various planets. Mercury, close up, you can see that cratering action I mentioned. Notice the sharp edges of the craters. Not a lot of weathering has happened since they were formed. Lots of circles in the solar system. Some craters have very sharp edges, some less sharp, and we'll see what that means. Maybe some of them remind you of Mickey Mouse. On Earth, circles don't always indicate craters. Alas, we've never looked at a planet and seen circles that, like these, are evidence of civilization happening on the planet. But you could imagine what they would look like were we to see evidence of such civilization and agricultural cultivation. Here's Venus and some circles on Venus. We'll talk about the meaning of these lines a little bit later. So it could be circles, it could be blobs, a technical term. Blobs would indicate something like a lake or a volcano rather than a crater. So making this distinction between a circle and a blob already starts to tell us something very different about what happened to cause the feature that we're looking at. This is Olympus Mons on Mars, a famous volcano. Here's Jupiter's moon Io, and you can see this isn't a crater, this is a blob. And that indicates volcanic activity, geologic activity, and we see more evidence of this when we look at this image at the upper left. We see gases being shot out from the surface of the planet, which is consistent with volcanic action happening. We see polygons on Mars, cracks in the surface that are evidence of more tectonic activity, and this mysterious hexagon on Saturn, polygons in space. This has actually been replicated in a lab. So what they think is going on, and obviously we can't test it, is that there's a spinning disk of stuff underneath the surface of Saturn, and they replicated this by putting water and glycerol and having something underneath the surface spinning around, and it flowed kind of chaotically for a while and then settled into this stable-ish hexagon pattern. So they think there's something rotating under the surface, and our evidence of that is the famous Saturn hexagon. And then there are straight lines, cracks, or faults, not to be confused with squiggles. Squiggles are exciting. Squiggles indicate liquid. Our main evidence for the prevalence of liquid water on Mars is all the squiggles that we see in the landscape. This can indicate erosion and wind. Look at these squiggles. We follow the water, where the water must have gone, and carved out some of the features that we see. Here's another picture, an image of the Martian surface. And here it is on Earth, lots of squiggles. You can see how the water formed all of these squiggly lines that it carves out. So when we see squiggles, that's evidence not of tectonic activity, but of the presence of liquid. Color can also indicate things, and sometimes the color isn't there when we look, only because our eyes don't see all of the possible wavelengths of light that are out there. So we've learned before that we can use false color to show different features of the landscape. Here, this image of the moon uses the different colors to indicate the presence of different elements, different chemical elements on the surface of the moon. That has much to teach us about the science of the lunar surface. And here's Mars in false color, again with the different colors showing different elements that are present on the surface, and so you can see some of their distributions. The albedo of a surface in astronomy is how reflective it is. So an astronomical object with an albedo of 0 is dark. It doesn't reflect very much light at all. And an albedo of 1 is extremely reflective and extremely exciting, because a reflective surface is often indicative of water ice on the surface. Water ice is extremely reflective. So if you see a lot of light coming from a planet, that could give important clues about the existence of water ice on the surface of that planet. And texture, of course, has much to teach us about the geologic activity that's present in the histories and current evolution of these planets. So look at this picture. What stories do you see? This is a picture of Mars. You see craters, and indeed the density of craters is a good indication of how old the surface is. In newer regions of Mars, there were craters that happened in the past, but they've gotten washed over by water or wind. So it's thought that the place on the surface of Mars where there are the most craters is the place that has been preserved for the longest time. It's the oldest part of Mars and can be studied for that reason. We can learn much about it for that reason. So we'd say that this part on the right of the image is older. It's been preserved for longer. And over here, there's been probably some volcanic activity based on the presence of these blobs, right? Because the blobs might indicate lakes or volcanoes. Here it's volcanoes. And so they spewed stuff out and probably covered over the craters that were there. Squiggles indicate water in the present, or in this case in the past. And so that has a lot to tell us. These straight lines that have been highlighted in this image are indicative of other tectonic activity that's happened. So we can learn a lot about planets and astronomical bodies in general from their surfaces and from images of their surfaces, and we'll be exploring that in this week's